Hello, welcome to the groundwater hydrology class. Today we are at the University of Parma, in Parma campus, in northern Italy, and today we will see how a steady-state pumping test works. My team and I will show you what you need for the pumping test, how it works, and results about the pumping test. What we are going to estimate today. Today we are going to estimate the hydraulic characteristics of the investigated aquifer. So we are estimating transmissivity and storativity coefficient. Okay, why you need a pumping test? If you are studying a groundwater contaminant problem, or if you are studying a water supply problem, for instance, you need to identify the best area for installing, drilling new water wells, you need to know the hydraulic characteristics of your aquifer. So you need to perform a pumping test, in particular a steady-state pumping test. To perform the pumping test, you need a well with inside a pump. You need at least one monitoring well to observe the drawdown in a closer point. You need a flow meter to record the flow rate. You need valves and the possibility to discharge the water.
This animation shows how water levels in a confined aquifer drop during a pumping test. As water is pumped out, a cone of depression forms and expands, showing how the aquifer responds over time.
To perform the pumping test inside the well, you need a pump similar to this one. The pump can take water from the well from this screen and pump along this pipe.
On the pumping well here we have some observation wells from which we will record the drawdown during the test. So how we can measure the water depth? At first we will use the manual water meter level that it's composed by a probe here and a graduated tape that we lower slowly in the well, and when the probe touches the water, so the water table, there is an electric circuit that closes, and then we can read the water depth with a reference. With respect of a reference point, usually is the top of the well casing. When we touch the water table, we close an electric circuit, and we have a buzz and a light here that indicate that we reach the water table. In addition to the manual water level meter, we can use an automatic sensor. Here is an automatic probe that allows us to record the measure with high frequency and high precision, and then we have an integrated data logger that allows us to download the data.
On the discharge pipe right after the pump, we install a magnetic flow meter that we are going to use to record in real time the discharge rate and the total volume of water flowing into the pipe. And we are going to use also this instrument that is called data logger for store all the data that we're going to analyze later after. It is important to maintain the discharge constant because variation can affect the interpretation of the data that we're going to analyze later after.
If you don't have a flow meter like the magniflow here, we can take the measure of the discharge manually. So we have a tank here, and we know that this tank is 30 liters. So we can record the time that we need to fill this tank. So let's start with the time. Okay, please stop the time. We fill the tank in 1 minute, so we know the volume of 30 liters. So we have a discharge of 0.5 liter per second.
And if you are in the field and you don't have a common power supply, you can use a generator.